Hello. So we are going to be looking at 2.3. It's on linear functions, and I'm just going to remind you what form a linear function takes on. It always looks in this form. It looks in y equals mx plus b form. So you're looking to see if each one of these down here can be written as y equals mx plus b form. So a few things. Um, Basically, the x cannot be in the denominator. For it to be a linear function. Some other things, your x cannot be squared. It cannot have a square root. If it's being squared, then it's going to be a quadratic or a parabola. X cannot be underneath the square root. So those are some conditions that exist for an equation to be linear or not. So let's go ahead and look at each of these. So y equals 3x. If I were to write that in mx plus b form, I would go ahead and say y equals 3x plus 0. Now I don't really need to put the plus 0, but if you were to say, okay, now I definitely can tell what the slope is 3 and the y-intercept there is 0. So yes, this is linear. All right, number 2 here says y equals negative 2 plus 5x. I'm going to put that in y equals mx plus b form. So I'm just going to rewrite the 5x first and then the minus 2 here second. So I can definitely see that the slope there is 5 and the y-intercept there is negative 2. If you remember, slope is m and the y-intercept there is b. So that's where I'm getting those values from. So yes, this is linear. Number 3 there, I'm going to go ahead. It says y equals mx plus b, so I need to bring the 2x over to the other side. So I'm going to do that by subtracting 2x from both sides. So I end up getting y equals negative 2x, and that's plus 10. So again, I can identify the parts here. My m there is negative 2, and my b there is 10. So then I'm looking there at number 4 there. It says f of x equals 4x squared. Now if you look up here in the linear form there, notice your x is not squared. It's y equals mx plus b. There isn't a squared term there. So I'm noticing right away that that cannot be linear, and that's what was one of our conditions over here. We said x cannot be under the square root and x cannot be squared. So that second one that we had there, x cannot be squared, that's squared, that's a parabola, it's not linear. So no, it's not linear. And I'm going to say because x cannot be squared to be linear. It's a quadratic. Could say it's a quadratic, not a linear as well. This one over here, we could go ahead and move over the negative 3 over x on the other side by adding 3 over x. So I get y equals 3 over x plus 15. But again, it's not mx. X is down here in the denominator, and when I look at that form up there at the top, it says y equals mx plus b. X, so this is not a linear, so no, it's not linear. And then y, because x is in the denominator. Number 6 there, you have 1/3 x equals y plus 8. So I'm just going to go ahead and bring 8 over on the other side by subtracting 8. So I end up on the left-hand side, I get 1/3 x minus 8 equals y. And I'm just going to reverse everything now. So I get y equals 1/3 x minus 8. So I can identify the parts. My slope here is 1/3. My y-intercept here is negative 8. So yes, this is linear. Number 7 there. And that's an interesting question there, number 7 there. So looking there at number 7 there, again, we're trying to identify whether or not that's linear or not. And yes, that is going to be linear, and I'm going to show you why. So I'm going to put a y in here instead of a g of x. It means the same thing. So y equals 8. So I can also, there isn't an x in there, so I can put a 0x if I wanted to, plus 8. And so then I could see that the slope there is 0 and the y-intercept there is 8. So yes, this is linear. And then number 8 there, remember, x cannot be underneath the square root, so no, because this ends up being a radical function. So no, because x cannot be under the square root. Oops, to be linear. So there we've gone through several examples there trying to figure out if a function is linear or not, or if the equation is linear or not. The next part we want to look at is if we can write it in standard form. So if you remember standard form is where we end up having in the form of ax plus by equals c, where b and c are positive or negative whole numbers, and a is a positive whole number. So down here, we're supposed to write each equation in standard form and then identify a, b, and c. So we're literally going to say a equals b equals c equals, and then we're going to, somehow it's going to be in that form of ax plus by equals c. So let's go ahead and let's look at this one. So we need to have the x and the y on the same side, but I'm going to bring the y over here because if I bring the x over here, I'm going to get a negative x. I'm going to get a, and I'm supposed to have a positive. A is supposed to be a positive whole number. So I'm going to bring the y over on this side this time. So I get 0 equals x minus y. And now I'm just going to reverse the order here. So I get x minus y equals 0. So looking at that, I can identify what a is. A is what's in front of x here is 1. I can identify what b is. There's a negative 1 in front of this. And I can identify what c is. C is what's over on this side, which is 0. So you always have to have it in that form. So this is part of my answer. X minus y equals 0. And then this a equals 1, b equals negative 1, and c equals 0. Those are all part of my answers there. Number 10 here, again, we need ax plus by equals c. So I'm going to go ahead and bring my y over here because I don't want a negative 5x over here. So bringing y over on this side, I end up getting 0 equals 5x minus y plus 1. Now I'm going to bring 1 over on the other side, so I got to subtract 1. And I get negative 1 equals 5x minus y. And now I'm just going to reverse the order, so I get 5x minus y equals negative 1. So there it is in standard form. Your a value here is positive 5. We always want a to be a positive whole number. B here is negative 1. It's what's in front of the y. And c here is just your constant term on the other side of the equal sign, which is negative 1. So we identified all of those parts. So now we're kind of at a little standing point here. So let's go ahead and work on, well, tomorrow you'll work on this assignment. So you're doing this at home at night. So you've taken all your notes. You're prepared for tomorrow. So when you come in, you can do your do now. And then you can work on the 2-3 worksheet 1 through 9 and 11. And I'll have that up tomorrow in class for you. So good job on your notes. And we'll see you tomorrow.